Good morning, everyone. Good to see a great turnout here. So, cost optimization on AWS. Just to give some idea what we're going to be covering today. We're going to look at the AWS difference. I'm sure you've heard this many times before. I'll keep it nice and brief. We're going to look briefly at total cost of ownership and what that means from not just an on-premises perspective, but also a cloud perspective. We'll look at how we address it in AWS. So this means how we look to lower your overall total cost of ownership and work it out within AWS. And then we get on to cost optimization. So how do we start actually driving some real value, lowering the overall cost of your services so you can start doing more with less. And then lastly, this is the only really technical part of it. I'm a solutions architect, so I need to do at least a little bit technical. We'll talk a little bit about cost-conscious design. This is where you can work with your solutions architects, your ProServe, your technical account managers to understand how you can start using different AWS services to drive costs lower again. And then finally, some takeaways. What can you do now in the next week, in the next month, to start lowering your costs and then start doing more with less? Okay, so I'm sure you've heard this before. What sets AWS apart? Our experience. We've been building and managing cloud services since the mid-2000s. We've got more than 120 services, ranging from the sort of core IaaS services to some really high-level services, and we'll talk about the differences between those from a cost perspective later. Global footprint, 18 regions, 55 availability zones, more than 119 edge locations. And really, again, coming into the pricing philosophy, we're driven by the Amazon culture of the virtuous circle. The more economies of scale we get, the lower we can make the prices. So to date, we've done more than 60 or 66 proactive price reductions. And lastly, when you're looking at building solutions, it's not just the capabilities that AWS have. We've got tens of thousands of partners, lots of products in the marketplace that help you deploy services quickly and easily. So why? So again, if I look at where people have come from, particularly from public sector organizations, traditional infrastructure, you have to buy equipment. You have to manage it. You have to own it. You have to insure it. You have to deploy it, support it. Typically, that involves contracts. That involves procurement, involves testing, involves a lot of cost. By comparison with AWS Cloud, there's no upfront expenses. You pay for what you use. Very important in the public sector. This is something I see come up frequently, time and time again. The improved time to market and the agility, the ability to do things fast, to try things quickly, to fail and move on, is a real big differentiator for AWS. You can scale up and down on demand, and we're going to talk about how that can help improve your cost optimization. And lastly, of course, it's self-service infrastructure. So you don't need to engage with lots of consultants to start going. You can use it yourself. We've got lots of documentation online, and you can also work with our partners. Okay, so if we look at what total cost of ownership is, it's the comparative total cost of ownership analysis. And that's both the acquisition and the operating costs for running an infrastructure environment, end-to-end, whether that's on-premises versus AWS. That's what we're going to try and address and look at in this session. So when we look at TCO for on-premises, all right, we've got traditional data centers and co-location. That's going to be the areas we're going to be focusing on. And what you'll find is actually it's very difficult to do a true TCO between the two because the things work in different ways. So we're going to look at the different components that make up a TCO and how we can actually identify commonalities and identify where you can start assessing differences. But comparing TCO isn't easy. And we have a team that can help with this. We also have some resources dedicated to TCO on our website. I will share the links for that at the end of the slides. So what do we look at with a typical TCO consideration? So the first and obvious one are typically server costs. That's not just the physical server itself, but it's hardware, it's the servers, it's the racks they sit in, the power, the top of rack switches, the maintenance, any software that goes onto those servers, whether that's a virtualization capability or bare metal, any licenses, and obviously the facilities cost, the power, the space, the cooling that's needed to support those servers. Then we have the same for storage. Most organizations will be looking at some type of hardware-based storage, whether that's SAN, whether that's NAS. You also need the fiber channel switches, the networking capabilities, the software, whether that's backup or RAID capabilities, and again, the facilities, the space, the power, the cooling. Again, network. So this is how you get from your top of rack switches to your core, your distribution, your aggregation layers, out onto the internet, out onto other premises, and so on. And again, the software that's related to that. Once again, this all takes up space in the data center. Then some of the things that some people include in TCO, some people don't, IT labor costs. So the people needed to admin all of this, to manage it, to install, unbox the kit, and so on, how you manage the storage. And then lastly, some of the things that quite often get overlooked in a TCO are things like the project planning. Just going through a procurement process to order 100 servers isn't trivial, particularly for a public sector organization. It needs to be in procurement organizations and so on. You need to then receive it, build it, install it, test it, and so on. So it can be quite difficult, and sometimes those costs are overlooked. And lastly, of course, there's some business value. Now, this is almost always overlooked in a TCO. What are the costs of delays if your hardware is delayed? What happens if something turns up and it doesn't work? And what value are you losing by not being able to deploy something within seconds, within minutes, as you can do on AWS, when you're actually waiting for infrastructure to come? So those are the sort of things that we typically look to try and cover in a TCO. So what's normally included in it? So we break this down, and there are sort of 8 sections that we tend to look at, from infrastructure to capacity and so on. And actually, in a traditional TCO, we typically only see one of those come up, the infrastructure comparison. How much is an on-premises server compared to an EC2 instance? We typically see there's some issues around cost avoidance, workforce productivity. So another quote you'll often see is it's easier to manage servers on AWS, so you need less admins per 1,000 servers that you manage, and any cost avoidance in terms of being able to do things quickly and easily. What quite often gets overlooked in a TCO are things like the ability to capacity plan. You don't need to plan months and years in advance for your infrastructure. You can scale up and down very quickly, and we'll drill into that in more detail later. Again, accelerated time to value of market is a really key one. If you take one thing away from this, and one thing from this entire conference, from my point of view, AWS lets you be agile. That's really, really key. Okay. So on-premises capacity planning. So it's not just us saying this. There's been studies that have said that on-premises compute environment is typically massively underutilized, to the extent that around 50% of infrastructure can be wasted. Now, those figures will depend on your organization and how hard you drive that. But in essence, these are studies by people like Gartner, McKinsey, Upside Institute, all sort of state that you have a lot of unused capacity within the data centers. So why is this underutilized? Well, typically because most organizations will have to try and plan for peak load requirements when they're building infrastructure. And that peak can come in different ways. You can have workloads that are spiky. So it may be completely random when you get your hits, whether that might be a news item if you're doing news stories, or it might be because of the weather, things like that. You can get some that are peaky for part-time. So it may be that at certain times of the day, your infrastructure becomes demand. And then there's the sort of the longer-term cyclical demand, so things like Black Friday, particular times of the year where you know that you're going to get the demand. So all of those give you different peaks and troughs in terms of your workload. But we build for peak. And why do we build for peak? Well, what we typically do is we have a fixed capacity, and then you're using somewhere in amongst that capacity, and then something happens. And I've seen organizations this has happened to. Suddenly, you get the oh no moment where the infrastructure isn't sufficient for your demand. It goes above. There's that, okay, what do we do? And that red shaded bar there shows the amount of services or utilization that hasn't been realized because the service couldn't cope. So that could be downtime. It could be lost customers. If you're a retail organization, lost revenue, the impacts, it can be quite impossible to measure. So what typically happens in an organization when that happens is management says, don't let it happen again, and they buy more kit. And then suddenly you've got even more spare capacity for your normal workload. But, and this always happens, it happens again. And so you then build for the next spike. And this carries on and on and on. And so what you end up doing is chasing reactively the peaks that happen in your business. And you're always fighting a losing game. So just to summarize, in terms of when you're exploring TCO, there's a few questions you can look at and ask yourselves and how you're going to manage this. When you're a capacity planner, how do you plan? How many servers have you had added in the past year? How many are you planning to add next year? Can you turn your hardware on and off? Have you got any form of on-demand capability so that you only pay when your servers are running? When you do use them, how are they being used? Are they being used all the time? Are you driving lots of value at 80, 90% utilization, or are they sat there idle a lot of the time? How much do you have to over-provision for those peak loads that we said? Or do you accept the fact that occasionally customers are going to experience issues because you haven't got the budget to manage those? In terms of overall operations, what are you going to do? Are you going to run out of space in your data center? Every time you add that infrastructure to peak, you take up more space, capacity, power. In many instances, I've seen data centers with lots of physical space left, but actually no power left to do it or no cooling left to do it. So there's impacts across different areas. What was your last year's power utility bill? Do you actually know your power utility? Is it separated out, or is it just come into one great utility bill? Certainly this is an issue I see a lot in the education and public sector markets, where quite often power demands for on-premises infrastructure aren't separated out. And have you budgeted for the fact that when you're drawing, when your infrastructure is heavy utilized, you're drawing more power than when it's averagely utilized? And lastly, if you're on AWS, have you optimized? Are you cost optimized? And hopefully by the end of this session, you'll understand some of the approaches for doing that. So how do we lower TCO within AWS? So firstly, we remove over-provisioning. There's no need to over-provision in AWS. You can move to a pay-for-what-you-use model, and we'll talk about how to do that. Second option is economies of scale. And I'll talk about why using a hyperscale cloud provider like AWS will allow you to drive those economies of scale. We also support lots of different pricing models to support variable and stable workloads. So if you've got a workload that runs 24/7, there's a separate pricing model that we can recommend compared to something that's very spiky or on demand. And then lastly, as you use more infrastructure, as you use more of AWS, we have pricing models that help drive those costs down further. So traditional approaches to capacity management, just to sort of recap on this. This is where we build to peak load. You can see that we've got capacity that's unused in particular parts of the day. If you build to average load, which is what some organizations do, you end up being over capacity at certain times. And in those situations, you start experiencing problems with performance and scale and so on. So what we recommend is we lower over-provisioning via what's something called elasticity. So within AWS, if you look at traditional EC2-based infrastructure, we've got services called auto-scaling, which allow you to react dynamically to changes in load. As the service becomes more popular or you get more load, you can increase the capacity within your infrastructure, and then it turns off again when you've finished using it or when that demand is gone. What this means is actually your capacity load changes dynamically based on the time of the day of the week, and so on. And so you can actually see that graph beginning to move. And so your wasted infrastructure, that blue shaded area, is a lot less. And most importantly, you're also not being under-provisioned, and therefore you're not experiencing service outages. Okay. So I've talked about economies of scale. So for us, continually lowering prices is in our DNA. It's driven from our Amazon corporate ethos. And the way it works is effectively, the more customers we get, the more AWS usage is driven. That means we order more infrastructure. By doing that, we can drive higher economies of scale. That allows us to lower costs. In return for that, we pass on those lower costs in form of reduced pricing. And then that drives a virtuous circle. We get more customers as a result. So the more use we get, we see a sort of virtuous flywheel to increase that capability. And the way we also drive that is through infrastructure innovation, so getting more out of our kit. We expand globally, so we have lots of regions, lots of footprints, new features and services that we hope customers will use and make best use of. And we pass those savings along. Okay, so now we're going to go a bit more detail into EC2, so our compute service and the different pricing models we have. And what we have here is we have traditional on-demand. So this is where you pay for what you use. When we started, we charged per hour. Now for many of our EC2 instances, particularly if they're Linux-based, we now charge per second. So when you use them, you pay for it. When you turn them off, you stop paying for the usage of that. We also have something called reserved instances. This is great for workloads that need to be constantly on. And we'll show how we can combine on-demand and reserved workloads in a little bit. And then lastly, we have something called spot instances. So spot instances allow us to tap into the unused capacity of AWS. And that means that you can run ad hoc workloads or sort of non-production workloads or batch workloads with massively reduced costs, subject to a couple of caveats that we'll talk about. So when to use reserved instances. So if we take this as a typical demand profile for some use cases, what we can see is that there's always a point below which we don't use, the usage doesn't drop. So the shaded area at the bottom shows where we can look to reserve instances. This means we know these services are always going to be on. We can make a reservation, and we can get a discount as a result for making that commitment. In comparison, the cyclical bits, so the peaks, will be dealt with on-demand instances. We only need to turn them on for parts of the day. We pay per second for the time they're on, and then when they're off, we don't need to use them anymore. We don't need to pay for them anymore. And the benefit of EC2 reserved instances is very great. So it can be up to 75% plus savings and capacity reservation when you make a reserved instance request. In return for reserving an instance, you commit to that for either 1 or 3 years. And it's not just EC2. So we have EC2, but at RDS, our managed database service, DynamoDB, our NoSQL service, Redshift, our data warehouse, and our in-memory services, Elasticache, all allow you to make reserved instance purchases. And in fact, now Elasticsearch also does that, so that was launched a few weeks ago. So all of these allow you to make commitments in return for significant discounts. At the other extreme are spot instances. These allow you to bid on spare Amazon EC2 capability for up to 90% off the on-demand price. This is great for applications that have really flexible start and end times. So if you have a batch workload or it's something that you only need to run occasionally, perhaps you want to do some ad hoc analysis of a big data set. It also allows you to generate applications that are only feasible at very low prices. So we have some customers who run 100% on spot and follow the lowest spot model across different regions around the globe because the only way their business model makes economic sense is to get that huge discount that comes from spot pricing. And it's also great for users with urgent computing needs for large amounts of additional capacity. So if you suddenly have a requirement because of a change in regulation or something where you have to do something very quickly, then you can use the spot capacity in one region or in lots of regions to start driving, get access to that compute capability quickly. With spot, the rules are simple. So the market sets the price. So the more capacity we have of a particular instance type, the more we can reduce the price from a spot point of view. As demand grows from that, from our on-demand and reserved instance usage, the spot price will go up. What you find is you never pay more than your bid, though, and you will pay the market price. So if the spot price is 10 cents per hour, you bid for 20 cents per hour, you will only pay 10 cents per hour, and you will if that price goes up, you will stop paying when you get to 20 cents per hour, because when you exceed that price, we give you a 2-minute warning and we terminate your instances. This is why it's not suitable for every workload. Don't run your production website on spot unless you've got some really, really good load balancing capabilities. But for those use cases, actually it works really well. And the fact you get notifications programmatically means you can start reacting to that. So it may be when you get the 2-minute notice, you spin up some on-demand instances to take on the load. Again, there are lots of different ways of doing that. We've got lots of partners in the marketplace who can help with that capability and actually help you run everything. We've got a program as well called the Research Cloud, the AWS Research Cloud program, which is targeted at educational institutions. And we've got a lot of information in there from marketplace partners who allow you to build HPC clusters on spot capabilities. And you end up effectively building an HPC cluster for the price of a coffee. Nextly, in terms of how you can drive benefits from pricing, is our volume-tiered pricing discounts. So this is where you get charged a certain amount for the first amount of storage you use, and then for additional storage, you pay less, and so on. So you're benefiting from aggregating your use. So as an example, and these are prices from the UK region, if you look at the first 50 terabytes per month, you charge 2.4 cents per gig. For the next 450, you're charged 2.3 cents per gig, and then it goes down to 2.2 cents per gig. Doesn't sound like much, but when you're starting to talk into petabytes and petabytes of storage, those costs begin to become significant. Okay, so those are the sort of capabilities we have, but where can we go in terms of making use of those, and how can we help you make best use of those? So this is where cost optimization comes in, and this is how we effectively model it. So what we say is on-premises starts with a particular pricing point, and what we typically see is when an organization looks to do a simple lift and shift of that infrastructure to AWS, they will typically get some savings. But that saving isn't huge, and it depends on the type of workload. It can be big, it can be small. But this is typically where a traditional TCO comparison stops. You're comparing the on-premises price to the EC2 price. From our point of view, that's where the journey begins. So then we have something called instance right-sizing. If you've just migrated a server with 16 cores and 128 gig of RAM, do you actually need that? Is that just there for your spare capacity, or do you genuinely need it? And we've got tools that allow you to monitor the actual usage for that, and then over time you can start saying, actually, that could be something with 8 cores and a 64 gig of RAM. Because of the way our pricing works, if you halve the instance size, you halve the cost of that instance size. So immediately you're looking to get savings. Because you haven't invested in upfront commitments or you haven't bought the infrastructure, you can do that without incurring a cost. We then look at improved elasticities. This is where we're talking about how we follow the demand model rather than over-provisioning for capabilities. Next is storage optimization. I haven't touched about this yet. I'll talk about it briefly. But are you using the right type of storage? Do you need extra fast SSD disk, or do you need some high-throughput sequential disk that may be cheaper? Can you actually store a lot of your data in S3 as object storage? Or could you store it through a CDN capability like CloudFront? So by the time you've done these, we get to what we call an optimized lift and shift model. So this is where you've reduced the cost further because you're making some of the benefits, some benefit and use of AWS capabilities. After that, we do some measuring, monitoring, and improvement because we always want to make sure that we're keeping a tag on what you're doing and how that infrastructure is being used. Then we can start looking at serverless architectures. And in my point of view, I think that bar there is pretty low. I think that can massively reduce the cost depending on the type of workloads you have. Because from a serverless architecture, you typically pay per event. So if your infrastructure is not serving anything, you don't pay anything. If you get hit for 10 requests a second, you pay for those 10 requests per second. So it's a completely different pricing model. It requires some thinking. We'll talk about that a bit later. But it can be really significant for certain types of use cases. And then lastly, you may decide to make use of some managed services, either from AWS or from a third party, that will, again, help you optimize from a management perspective. And what that ends up really is you have a re-platformed AWS optimized infrastructure that can be significantly less than your lift and shift price. And as always, the economic case for migrating into AWS improves the more you take into account. If you work with AWS account managers, if you work with AWS solution architects, we're always happy to help with this because we've got experience of doing this. So please reach out to whoever you know in AWS. So from our point of view, we've got some pillars of cost optimization that we like to remind people of. Firstly, look at right-sizing your instances. Think about what you're using. Make sure you get those right. Then you look at increasing elasticity. So once you've got those, we can think about how we can be flexible on that elasticity. Make sure you pick the right pricing model. The first and the third are very much linked. So don't make a reservation before you look at how much whether you've right-sized your instances or not, because you don't want to reserve an instance that's too big and you don't need. Match your usage to your storage class. And also always measure, monitor, and then that can feed back into your cost optimization. Okay, when we look at right-sizing instances, select the cheapest instance available whilst it meets your performance requirements. Remember, you can scale automatically. In the cloud, we look to scale horizontally rather than vertically. So instead of actually adding more CPU or compute capability per server, think about how your workloads can scale to add more servers horizontally. And we'll talk about why that's a good thing in a bit. Look at the CPU, not just the CPU, but the RAM, the storage, and network utilization to identify whether there's any potential instances that can be downsized or changed. And then a lot of this is driven by Amazon CloudWatch metrics, so you can set up alarms and so on to look to see what's happening within your infrastructure. As a rule of thumb, right size, then reserve. If you're in a pinch, reserve first, but that is a very edge case. That's typically something you talk to us about before you do that. When we look at right size and elasticity to reduce cost, more smaller instances versus fewer larger instances to deliver the same workload can be pretty beneficial. So if we look at this, it's a typical usage pattern over a period of time. Doesn't really matter what that time is. And what we'll say is that we meet that workload by, in this case, deploying 29 M5 large instance hours. So for the first 3 hours, we've got one server. Then the demand goes up such that we need a second server. And then after about 6 hours, it goes up, so we need 3 servers. If you look at that diagram, you'll see that the red line cuts across the bottom part of the bar quite a lot. That means that instance is being underutilized. So whereas in sort of hour 1, 2, 3, 4, 5, both instances are quite heavily used, but by the time you get to hour 7, the third instance is probably only 20% utilized. Okay, so what can we do about that? Well, let's change it for T2 mediums instead. If you notice, we use more of them. We use more hours, almost twice as many hours of T2 mediums, but they fit that graph a lot tighter, so there's less wasted usage. So in this example, we're saving maybe $100 a month. May not sound like much, but this is for one workload. If you have 1,000 workloads, that's a significant saving. And the only thing you're doing is changing the instance size. So again, think about your usage profile, think about how that fits in, and wherever possible, choose the smallest possible instance that meets your requirements, because you can scale horizontally, which is what that is talking about. Pardon me. So workload scheduling. So this is another key aspect, and this is one that's quite often overlooked, but this is the simplest, the quickest way you can drive lower costs in your organization. If you have an instance that's running 24/7 in a particular time period, you pay 100% of the cost of that. It's fairly obvious. If it's running all month, you pay the full monthly cost. If you only run it 5 days a week, you actually save almost 30% of your cost by turning it off on the weekends. If you then turn it off overnight as well, you save 65% of your overall costs. And lastly, if you optimize it for only business hours, you can save around 70% for non-production workloads. Because remember, when an instance isn't running in AWS, you don't have to pay for it. So think about your production workloads. They typically need to run 24/7, but your dev, your test, your pre-prod environments, maybe your HR systems, maybe the systems that only run occasionally, turn them on when you need them, turn them off when you don't. Now, this can be complicated, so we've actually created a solution for this. It's called the AWS Instance Scheduler. It's an AWS provided and managed solution, so you deploy it as a CloudFormation stack. The URL's in the picture there. And these slides will be available as well, so don't feel the need to copy it down. We'll publish them afterwards. But you can create custom stop and start schedules. It works with both EC2 and RDS, our managed database service. It's deployed very easily using CloudFormation. And you choose the instances you want to stop and start by tagging them. So you tag them with a particular type of workload, and in response, every 5 minutes, this system will look to see if that instance should be started or stopped, and then manage that for you. Full documentation is on there, but a really useful tool, very quick and easy to do. If you target it for your non-production workloads, you can massively reduce your costs. Okay, so we then talked about matching usage to storage classes. So from our point of view here, we have a range of different storage capabilities that we talk about within AWS. Amazon S3 is our object store, massively scalable, very cheap, high performance. It's designed to store and access any type of data over the internet or privately through gateway interfaces. Amazon Glacier is our low-cost archive service. So it effectively takes S3 objects and it can archive them into a lower cost tier of storage. It's great for long-time archiving, for data that doesn't need to be accessed very frequently, but that can massively reduce your price as well. When you look at storage, you need to attach to instances, so block storage. We have Amazon EBS. We have different types of block storage, so we have very high-performant storage, which is designed for 30,000 plus IOPS, and then we have slower storage that is designed for sort of more archive or sequential throughput. So choosing the type of EBS that you want is a good thing. Storage Gateway allows you to deploy either a file interface or a tape interface or a SAN interface into your on-premises infrastructure or into AWS, and then back that with things like Amazon S3. So you can present file, disk, or tape interfaces into AWS, but have them backed up by Amazon S3 and all the capabilities that offers. Elastic File System is our managed NFS service, where you can effectively have that available within a VPC or connected on-premises using Direct Connect. You can make writes into those, and it's just a very simple, fully managed, highly scalable, highly available system. And then lastly, the other stream, Amazon CloudFront, is our content distribution network capability. So this is where, again, if you look at workloads that are typically very read-intensive, it's lower cost of storage and lower cost of distribution to the end users if that content is cached in the CDN at the edge rather than just within AWS. The other thing I will talk about is serverless architecture. So just as a very brief show of hands, who here has heard of serverless? Good, so most people. Who here is using it? Okay, so less, but still a significant number. So from a public sector perspective, I'm seeing a lot of take-up of this from organizations because it completely changes the cost model and massively increases the agility and the speed you can get to market. And there's some reasons for that. There's no service to manage. Everything you deploy in a serverless architecture, by definition, is serverless. It means you manage the underlying, AWS manages the underlying service. You just make use of the capabilities. Well, it also means you've got very flexible scaling. If you stand up an API gateway and nobody uses it, you don't pay for that. If suddenly 1,000 people hit it, you scale and you pay for those 1,000 requests until those requests stop, and then you stop paying for it again. So it's great for bursty workloads without you having to worry about having a core fleet underneath the hood that keeps things up and going. It's highly available by design, so it uses our managed services capability. We've architected all of our serverless architectures to be highly available. And lastly, as I mentioned before, there's no idle capacity. So when it's not running, you don't pay for it. We've got some great examples of serverless architectures on the website, aws.amazon.com/serverless, where it talks about things like serverless websites, dynamic forms, processing of batch data, and so on. So again, it's worth checking out. It can be quite a challenge, especially if you've got a traditional on-premises infrastructure. It may not match every use case, but where you can, if you can think about serverless, again, that can massively reduce your costs. Amazon CloudWatch. So this is one of our key services that help you understand what is going on within AWS. And what we have is it allows you to monitor AWS services, not just EC2 instances, but performance of things like API Gateway, Lambda, which is our serverless compute capability. It can manage RDS, look after RDS instances, and so on. You can set alarms. You can start saying, when I see a CPU threshold of 90% plus, more than 5 minutes, I want to trigger an alarm. And because we're in AWS and because we have lots of programmatic access, you can then react to those alarms. You can say, OK, so I'm seeing that my servers are at 90% utilization. Let's add some more servers into that. Let's auto-scale our environment up for a few hours. Then when those alarms turn off, because we've then reduced the capacity back to, say, 70% utilization, we can then start scaling the infrastructure back again. So CloudWatch alarms are key for helping you auto-scale your environment. What we also do is allow you to define custom metrics. So quite often, your application might not scale based purely on CPU capability. It might be on the number of concurrent users, or it might be on the amount of RAM used within a particular application piece of code. What we allow you to do is inject those custom metrics into CloudWatch and then set alarms on those. So you can start reacting not just to standard metrics that we monitor, but any metrics as well that you can provide the data for. You can graph those. You can view statistics. You can see the average. You can see the percentiles, the 99th percentile of usage, and so on. And lastly, you can monitor and react to those resource changes. So again, programmatically respond to what's happening, make changes to your infrastructure dynamically, programmable infrastructure. When you're looking at metrics and targets, set up the metrics to define success and track progress. So think very carefully about what you're looking to achieve. Are you looking for optimum performance? Are you trying to really lower costs and will accept lower performance from a user perspective because you're very tight to a particular budget? You may decide to track particular metrics. So you might want to see, we want to hit a metric target of 80% of instances should be turned off on a daily basis. Non-production instances, that is, not production. You may want to look at how many you right size. So you may want to have some sort of check that makes sure that all instances are running at least 70% capacity, for example. When you're using reserved instances, it's really important you pay for effectively that reserved instance capability. If you don't run an instance, you're effectively wasting that RI capability. So we have tools, and I'll talk about those later, to make sure that if you've got reserved instances, make sure you're running them, make sure you're driving the best use of those. And always, what KPIs make sense for your particular workload? That's really key. We have a couple of tools to help with that. The first of those is something called AWS Trusted Advisor. Again, a very quick show of hands. Who's heard of Trusted Advisor? OK, so yeah, probably more than half. Trusted Advisor, from our point of view, is a service that automatically monitors your account, AWS account, and makes recommendations across a range of different capabilities around cost, performance, security, fault tolerance, and reliability. And what we do there is we say, programmatically check to see what parts of your infrastructure could be more optimized. So I won't touch on the performance, security, or fault tolerance, but from a cost optimization perspective, it will flag things like you've got database instances that are idle. So for example, you might have a database that's running at 1% capacity. Well, if that's running on, I don't know, M4X large, you might want to think about moving that to a T2 medium and reducing the price of that, because then you're still making use of, you're reducing the cost, but still able to hit the performance you need. And that will cover things like EBS volumes. It will cover things like load balancers, EC2 instances, and so on. And here you can see an example. So that's making examples of annual savings of around $2,700 based on the fact that 11 of the 15 RDS instances here appear to be effectively idle. So again, think about this, use this as a tool. It's a free tool if you're on business or enterprise support. Make best use of that and understand what's happening. We also allow programmatic responses to those as well, so you can start programmatically responding to alerts that are generated from Trusted Advisor. The next one is Cost Explorer. So we're continually iterating on this, but this is a great tool for drilling deep into the costs within AWS. You get it within the budgeting section of the console, and it allows you to start tracking metrics in terms of things like what's your usage of EC2. And you can start filtering by a very granular set of capabilities. So you could say, only show me things in a particular availability zone, or a particular region, or a particular type of service, or those that are tagged in a particular way. If you're a big customer and using multiple accounts and things like AWS organizations, you can start reporting across multiple accounts as well. So you can start seeing your spend across multiple accounts. We also add capabilities in here, such as showing how many of those are recovered by reserved instances, and also recommendations to help you understand where reserved instances might further reduce your costs. So again, a really good tool. If you have the chance to play around with that, highly recommend it. Okay, so that's the story so far. Cost-conscious design, this is the bit I said we're going to go slightly more technical. It's a way in which we help customers understand the different types of AWS services and where some are more appropriate fit than others. And what it means is, so for an example, a very simple example, should I use Amazon S3 or DynamoDB to store a particular type of data? And that may seem obvious, but actually it can depend. And we have a tool called Simple Monthly Calculator, which allows you to plug in particular metrics, such as the number of requests per second, or the amount of data stored, the amount of time you're storing it for, and so on, and then it will put out a price. And that's great for sort of doing budgeting and TCO, but actually you can use it to cost optimize your existing workloads. And we'll work through an example now. So here we've got a requirement where we want to do 300 writes per second. We want to do it with an object size of 2K. So every object we write is 2K in size, which means we're writing about 1.4 terabytes per month and about 770 million objects per month. So this is a requirement we have. And we want to decide whether we want to put that into S3 or DynamoDB. So what we do, we take those figures and we plug them into the Simple Monthly Calculator. So in this case, Amazon DynamoDB, what we're doing is we're saying, OK, the total size is 1,483 gigabytes. We put that in. We say that the object size is 2K, so we put that in terms of the item size. And we specify the number of writes per second. By doing that, what we then do is we can do the same thing, but with Amazon S3. So here we're saying we're going to put 1,483 gig in. And down here, we can see the different number of requests. So in this case, 770 million requests. Notice that different services have different pricing models. So we weren't interested in necessarily the objects per month stored in DynamoDB. But by using the Simple Monthly Calculator, we can get figures out at the end of it. And what we see is that DynamoDB, for this particular workload, will cost about $650 per month, roughly, compared to S3, which costs somewhere around $4,000 per month. So a fairly obvious win there for DynamoDB for this particular use case, which is great. OK. But then, what happens if we change just one of those parameters? What happens if we change the object size from 2K to 32K? So effectively, what we're doing now is that. What we end up with is a much bigger size of data. So now we're up to 23 terabytes per month. But everything else is the same. Same number of objects, same number of requests, just a different object size and the amount of storage. So again, we take those figures and we put those back into the system. So if we put it into DynamoDB, what we're seeing is now there's a bigger data set size, a bigger item size, and a bigger set of same number of items written. S3, bigger data size, same number of requests. This time, our DynamoDB price is $10,000 per month. Our S3 price is $4,500 per month. So immediately we can see that just a slightly different set of parameters means that a different type of service is more appropriate. So if we can compare scenario 1 and scenario 2, if you're looking at scenario 1, then we should be using DynamoDB because it's a lot cheaper for our particular use case. If we have a requirement to have bigger object sizes, then actually S3 makes a lot more sense. And in both cases, you can see that we're looking at potentially orders of magnitude price differences. So this is where it's a little bit more complicated because you need to understand your workloads a bit more deep than just a typical TCO. This is where you can engage with your solution architects, with partners, with ProServe to help understand these type of workloads. OK. So lastly, from my point of view, is what's next. So what benefits do you get from moving to AWS? So you get to trade capital expense for variable expense, which is a big one, and it can actually be a challenge for some public sector organizations who are used to buying stuff with 3 or 5 year CapEx budgets. That's something that's being worked on at the moment, and I think we've published a white paper very recently about how to help address that and answer those challenges. You also benefit from the massive economies of scale. You can stop guessing capacity. I've shown you the ways that we can auto-scale this. You get increased speed and agility, reduced time to market. Again, a really big one. You can focus your money on product development, not data centers. So you can really focus now on what you're doing, how you add business value. You can move away from what we call the undifferentiated heavy lifting. Let AWS worry about that. And lastly, you can go global in minutes. So for existing customers of AWS, a call to action. When you get back to your office or get back to your console, how many instances could you right size? Go and look at the metrics. Are you tracking the right sort of CloudWatch metrics for this? Could you do something to look at how you might change all your M4 2x larges to M4x larges. And if you do that, you half your price. What benefits could you get from using reserved instances? Again, if you're not sure, please reach out to your account manager, SAs, TAMs. We all basically really want to help you spend less with us. It sounds strange, but that's what we want to do. We want you to make best use of AWS, and in this case, using reserved instances. How many of the instances need to be running 24/7? This probably takes a little bit more planning, and you need more buy-in from the organization. I highly recommend you don't enable Instance Scheduler without telling your other business units, because losing instances when they're not expecting them can be a challenge. But if you do get those buy-in, and particularly when you do things like chargeback or showback to those organizations, if they can understand they'll save 60% of their costs just by not having them running on weekends, then they'll typically buy into that. And what you can also do, by the way, is you can extend that. So if you've seen things like the Amazon Dash button, the IoT button, what we've seen is organizations implement that. So if a developer does need access to their environment, they tie in a Dash button or an IoT button. They press it, it spins up their environment, and then after an hour, it turns it off again. And so if they just need it going, they just keep pressing the button every time they need their infrastructure. Very simple use case, but again, it helps balance that out between reducing your costs and giving the flexibility and control to your development team. And lastly, how many instances are configured for auto-scaling? So are you tracking your demand properly? Not just with EC2, but think of the other services as well. We now support application auto-scaling as well, so there are other things such as DynamoDB. You can change your provision for DynamoDB based on current requirements and CloudWatch metrics as well. Lastly, from my point of view, a few resources that you can look at. So aws.amazon.com/pricing. All our pricing is public. All of it's available on the website. It's pretty well organized. Our pricing can be complex at times. The reason it can be complex is because we really want to be granular about how we charge people. We don't want to charge you for things you don't use. And so quite often you'll see services that have different metrics, different dimensions for cost. This may mean that, for example, storage, you may get charged for the amount you store and the number of times you access it. The reason we don't just have an all-in cost is because some people store lots of data but don't access it very often. Other people store small amounts of data but have it really, really active use of that. And those use different components of our underlying capabilities, and we need to charge for those and manage those capabilities effectively for those particular use cases. That's why we have typically different pricing models. It's not to make things more complex for you, it's to make sure that you only pay for the resources that you're using. We have an online TCO calculator, so this is more of a sort of higher level comparing your on-premises data center into AWS. And then lastly, we have a Cloud Economics Center, which talks about a lot of the things I've touched on as well, plus how to build things like the business case and so on. And so I will go back if anyone's taking a picture of those. Okay, so that's it for me. Thank you. And we have 5 minutes, the usual plea. If you please enter feedback, we like to know what worked, what didn't for these sessions. I have got time for questions. I can either take them now or take them at the end, and I'll be around out in the hallway. So please ask if you have any. Yeah, so the question was, when will the slides be available? Typically, we try and get them up within a week of the event. But again, that's not something I've got control over. This is a session we've presented before. So if you look on SlideShare for the AWS section and for cost optimization, you will find these slides just with a couple of differences already there. So.